All right, in this lesson, we're going to be looking at significance tests for population proportion. And our objective here is to state and check the conditions for proportion testing, perform a significance test about a population proportion. So to do that, we're going to look at this example real quick. And there's quite a few steps to this, so it's kind of important that we get to all of them. So a confidence interval for proportion. A Pew Internet and American Life Project survey found that 392 out of 799 randomly selected teens reported texting with their friends every day. Our goal here is to calculate and interpret a 95% confidence interval for the population proportion of P that would report texting with friends every day. So, first we want to define what our population and parameter is. So the population in this case is all teens in the U.S., we'll just say that. And the parameter is the proportion that text friends every single day. We are told that the sample is random, so in this case, we're checking our three conditions here. We're told that the sample is random. 799 is way less than 10% of all teens in the U.S., so that meets the 10% condition, and that means that it's independent. And since the large counts condition is met, that means that 392 responded yes, so the other 407 responded no. Both of those are greater than 10, so the large counts condition is met as well. That means that the distribution is approximately normal. So because we pass all three of those tests, we can find our proportion. So again, you can go to your calculator and you can find, if you go to Stat, arrow over to tests, and then find the 1prop z int function. Just arrow up until it goes to the bottom of the list and find that down there. Then that takes care of finding this right here, your confidence interval, basically. But remember that we need to write this equation out as is in order to get full credit on the AP test for that. So what we also need to do is we need to find this z value right here. And you remember that we can do that by going to second vars and inverse norm. Sorry, I forgot the function for a second. So second vars and inverse norm, and that's going to help us find our critical value, our z value right there. And then once we found all of that information, once we've plugged it in, we can say that we are 95% confident that the true proportion of teens who text their friends every day is between 45.6% and 52.5%. But remember that we need to write our formula right here. We got to be familiar with that in this case. So if we are asked to perform a significance test simulation for a population proportion, there are many things that have to be done for this. The first thing that has to be done is we need to identify the population and parameter in question. That's what we did right here. We identified the population and the parameter of what specifically we were talking about. From there, we want to state the null and alternate hypotheses, basically. And we didn't do that in this last instance, but as we're looking forward, that's what we're going to have to do. We're going to have to state the null hypothesis, which is there's no change to the population, and the alternate hypothesis, which is there's some change to the population. And that change can be one-sided or two-sided. So one-sided meaning it can either be greater than or less than the null hypothesis, or it can just not be equal to the hypothesis, which is what represents a two-sided equation. From there, we need to state the conditions and confirm that they are met. So that is what we did right here. We stated that the sample was random. We stated that it was independent, which means that the sample can't be larger than 10% of the population, and we stated that it was a normal distribution, and so for proportion, specifically, the large counts condition must be met, meaning that the percentage for failure or the proportion for failure, or for success, must be greater than 10, and the proportion for failure must be greater than 10 as well. So both must be greater than 10, basically. After that, we need to calculate and test statistic and p-value. So our test statistic is how far an observation is from the mean in standardized units, and that's essentially just finding this z value right here. So we're taking the statistic minus the parameter divided by the standard deviation right there. And we can solve all of that and make sure that your standard deviation is based off of whatever you're testing in your null hypothesis in this case. So if our null hypothesis in this case, which they didn't even give us a null hypothesis, but we'll look at that when we're looking at future examples. But essentially, you want to make sure that your standard deviation is not based off of p hat, but based off of p right there. Your p-value is the second thing that we need to calculate, and that's the probability that a given observation is likely to occur given a known mean. So all of that, this as well as this, must be calculated, and then you'll have to state kind of a conclusion to all that. But all of that needs to be answered or said in the process of answering these types of questions. So just looking at this example, let's take a crack at it. Our virtual basketball player in the previous activity claimed to be an 80% free throw shooter. Suppose that he shoots 50 free throws and makes 32 of them. His sample proportion of made shots is now 32 out of 50, or about 64%. This result suggests that he may really make less than 80% of his free throws in the long run. But do we have convincing evidence that his proportion is actually less than 80%? In this activity, we will perform a simulation to find out how to do that. So again, the first step is to state the population and parameter. So the population is all free throws made by this player. The parameter is the proportion that is actually made. Our null and alternate hypothesis, our null hypothesis is that his proportion stays at 80%, or that the shooter makes 80% of his free throws. Our alternate hypothesis is that that's actually less than 80%, or the shooter makes less than 80% of his free throws. We would assume that these 50 shots are a random sample of all of his shots, so that random condition is met. 50 is going to be way less than 10% of all free throw attempts. So this is considered to be independent. And since he made 32 and missed 18, both of those are larger than 10, so the large counts condition is met, and the distribution can be considered approximately normal. When we're going to calculate the test statistic and p-value, again, we are basing it off of the proportion from the sample, or p hat, minus the actual proportion based off of the null hypothesis. So again, we're basing it off of our null hypothesis right here at 0.8. Then we're creating a standard deviation based off of that null hypothesis as well. And that value right there, the test statistic, is going to give us a z-value or z-score of negative 2.828. Now, when we go to find the actual p-value for this, what we have to consider is that we're testing to see if the proportion is actually less than 80%. So what that means is that we are testing to see the proportion that p is less than this value right here. So what that means is that we have to stick that in our upper bound of our normal CDF function. So we have to input a really low number in for our lower bound, the z-score that we got up here into our upper bound, and then we can assume that this is a normal distribution because we've tested that. So our mean can stay at 0 and our standard deviation can stay at 1, which gives us a p-value of 0.0023. So there is only a 0.2% chance that an 80% free throw shooter will only make 32 out of 50 shots, which is an alarmingly low percentage chance that that would actually happen. So since that value, since that p-value that we just found is less than alpha, and we could set, alpha to be whatever, and it's probably still going to be lower than that, then we would reject the null hypothesis that this free throw shooter is actually claiming that he's an 80% free throw shooter. So there's convincing evidence to believe that the shooter is not 80% accurate. So again, all of this must be done in order to fully answer a significance test question. So first we must state hypothesis do we want to test, and at what significance level, and then we want to define any parameters that we use. And that's exactly what we did. We defined our parameters, defined our population, and then we defined what the hypotheses were. We did not define the significance level, but don't worry about that. Just worry about answering based off of parameters and hypotheses for the state portion of this. Our plan here is to choose the appropriate inference method or check the conditions. So once we have checked the conditions, that it's random, independent, and normal, then we're good with the plan portion. Right there. From there, we want to do. So we want to compute the test statistic, and then we want to also find the p-value, which is finding that z-value or z-score and the p-value itself. From there, we want to conclude. So we want to make a decision about the hypotheses in the context of this problem. So suppose the conditions are met. To test the hypotheses, that the alternate hypothesis is the actual proportion is equal to the null proportion. From there, we would compute the z-statistic. We know what we're doing with that. But kind of the important thing to note here is this visualization down here. Again, we're basing our visualization on the alternate hypothesis itself, or the actual p-value itself. And so when we're trying to calculate the p-value, if our alternate hypothesis state that the proportion is greater than the null proportion right here, then what we're testing is this tail right here, or the rightmost tail. If our alternate hypothesis says that our proportion is less than our null proportion, then we're testing the left tail right here. And if we're saying that the proportion does not equal the null proportion for our alternate hypothesis, then we are testing both tails, which means that if we are going to run this normal CDF function, if our null hypothesis said that p was not equal to 80, then we would have to multiply this value by 2, essentially, in order to get the actual accurate p-value for this particular problem, basically. So that's what not equal is essentially testing. But there's a far easier way to do that in the calculator than having to remember that particular step. So let's keep looking at these examples. This next one says the potato chip producer of section 9.1 has just received a truckload of potatoes from its main supplier. We recall that if the producer finds convincing evidence that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load from the supplier. A supervisor selects a random sample of 500 potatoes from the truck. An inspection reveals that 47 of the potatoes have blemishes. We want to carry out a significance test at the significance level of 0.05, or alpha is equal to 0.05. What should the producer conclude, basically? So again, we state our population and parameter. The population is that all potatoes, or is all the potatoes in the truck. The parameter is the proportion that actually has blemishes. Our null hypothesis is that the proportion that has blemishes is actually only 8%. However, the alternate hypothesis should be that the proportion is actually greater than 8%. So the alternate proportion is the proportion is greater than 8% that actually have blemishes. When we're testing our 3 conditions, we are told the sample is random. We will assume that 500 is smaller than 10% of the total population of potatoes in this company. And since 47 have blemishes, 453 do not. So both of those values are greater than 10, so the large counts condition is met. And then we can assume the distribution is approximately normal. Now, when we are running our proportion here, what we discover is that the proportion that's actually on the truck that does have blemishes was 47 out of 500. So that represents about a 9%. 9% of the potatoes have blemishes on them. Our sample, not our population. Our sample was 500, and our critical value of Z was 1.960. And so when we plugged all that in, we got a p-value that was actually 0.1215. So since 0.1215 is greater than 0.05, we will fail to reject the null. So there is not sufficient evidence to believe that the proportion of blemished potatoes is greater than 8%. So all of that has to be done in order to successfully answer that question. Now, if we want to find our z-value, our actual proportion, all of that basically, or our p-value, all of that, what we can do is where we go to find the one prop z int, we can go to find the one prop z test. So if you go to stat and then arrow over to test, so stat and tests, you should see, and then 5, I guess, you should see one prop z test, and it may be different based on the type of calculator that you have. It may not be 5, but you're looking for the one prop z test down there. And then what you can do from there is you are going to plug in 0.08 in this case for your null proportion. In this case, our sample of potatoes that actually had blemishes on them was 47, but the total number in the sample was 500. So we would plug in the ones that had blemishes based off of the entire sample. And then from there, this is where we kind of need to know what the alternate hypothesis is. We're saying that the actual proportion is actually greater than 8%. So what we would do is we would arrow over to where it's actually greater than the the null proportion. Our alternate is actually greater than the null proportion, then arrow down and hit calculate, and what it should spit out at you is this. So it does give you your z value, which again is one of the values that you actually need to calculate for this, and it does give you your p-value as well of 0.1243 in this case. It also gives you your p-hat as well, just taking 47 divided by 500. An AP exam tip based on using this. You can use your calculator to carry out the mechanics of a significance test on your AP exam, but there's a risk involved. If you give the calculator answer with no work and one or more of your values is incorrect, you will probably get no credit for the do step. If you opt for the calculator only method, you want to be sure to name the procedure one proportion z test and to report the test statistic at z is equal to 1.15 as well as the p-value of 0.1243. So in this case, it doesn't sound like you actually have to write out your formula as you put it right here. However, you do need to state that you used one prop z test to calculate this, and you need to list both the test statistic and the p-value right there. You cannot just give one or the other. Otherwise, you will not get credit for the do step of this. So just make sure that you write both of those down and you should be good. According to the Centers for Disease Control and Prevention website, 50% of high school students have never smoked a cigarette. Taeyeon wonders whether this national result holds true in his large urban high school. For his AP statistics class, Taeyeon surveys a simple random sample of 150 students from his high school. He gets responses from all 150 students, and 90 say that they have never smoked a cigarette. What should Taeyeon conclude? Give appropriate evidence to support your conclusion. So we should note that this problem right here is a significance test, basically. So we have to, when it says give appropriate evidence to support your answer, we have to give appropriate evidence based off of everything that we know about this test. So we have to list the proportion and the parameter. So the proportion in this case is all students at Taeyeon's high school. The parameter would be the proportion that have never smoked a cigarette. Or the parameter, excuse me, would be the proportion that have never smoked a cigarette. Our null hypothesis would be that proportion is 50%. So the null proportion is the null is the proportion that have not smoked a cigarette is 50%. The alternate is the proportion that have not smoked a cigarette is not 50%. We are told that the sample is random, so we want to make sure that we state how all three tests are true. We're told that the sample is random. We should assume that 150 is not more than 10% of the large high school, so the 10% condition is met, and that means that the test is independent. Since 90 said yes and 60 said no, both of those are greater than 10, and the large counts condition is met, and the distribution should be considered approximately normal. So from there, again, we can run this stat, arrow over to tests, go to one prop Z test, and plug in our information. We know that our null proportion is 50%. The number that participated in the sample is 150, and the number that said that they had not smoked a cigarette was 90. So we put 90 in for X, 150 in for N, and we are looking for our alternate hypothesis says that our proportion is actually not equal to the null proportion. So we want to make sure that we select not equal to. So once we've done that, we can hit calculate, and it spits out our test statistic as 2.449 and our p-value at 0.0143. So since 0.0143 is less than 0.05, or alpha in this case, and we're just saying that alpha, I don't think they actually told us that alpha was 0.05, but we went ahead and assigned alpha as 0.05. So since that's less than 0.05, we will reject the null. So there is sufficient evidence to believe that the proportion of students at Tayons High School that have never smoked a cigarette is different from the national proportion of 50%. Let's look at one more example here. So according to the National Institute for Occupational Safety and Health, job stress poses a major threat to the health of workers. A news report claims that 75% of restaurant employees feel that work stress has a negative impact on their personal lives. Managers of a large restaurant chain wonder whether this claim is valid for their employees. A random sample of 100 employees finds that 68 answer yes when asked, does work stress have a negative impact on your personal life? Is this a good reason to think that the proportion of all employees in this chain who would say yes differs from 0.75? Support your answer with a significance test. So again, you can be asked, support it with a significance test or give appropriate evidence to support your answer. Either one, you should perform the significance test. So the population is all workers at this large restaurant chain. The parameter is the proportion that felt the stress negatively impacts their personal life. Our null hypothesis is that the proportion is 75%. So the null is the proportion of workers for this chain that felt the stress has a negative impact is 75%. Our alternate hypothesis is the proportion of workers for this chain that felt the stress has a negative impact is different from 75%. When we run or check our conditions, we are told that the sample is random. We should assume that 100 is less than 10% of the large chain. And since 68 said yes and 32 said no, both are greater than 10, the large counts condition is met and the distribution is approximately normal. From there, we can go to stat tests, arrow down to one prop Z test right there. We're putting in our 75% for our null proportion. We know that the total number in the sample was 100, and 68 said that yes, work does actually have a negative impact on their life. So 68 would represent X right there, and we know that our alternate hypothesis is that we're testing to see whether the proportion is not equal to 75%. So we would select our not equals to option right there for the proportion. Then just hit calculate. Make sure that we state our test statistic at Z, which is negative 1.617, our p-value of 0.106, and since 0.106 is greater than 0.05, we would fail to reject the null. So there's not sufficient evidence to believe that the proportion of workers for this restaurant chain that believe the stress negatively impacts their personal life is different from 75%, which is actually kind of depressing when you really think about it. But important thing to note, just make sure you answer the entire question and everything. I know that this is long, but you have to make sure that you answer with all parts. Otherwise, if you're asked this question on the AP test, you will not get credit for parts that you should be getting credit on.